Hi, and welcome to our second to last video for level 3 differentiation. Kind of funny, we really should have put this as the very first video for level 3, in fact probably at level 2 as well, because this is finally the video that shows you, after all the differentiation you've been doing, how it all started and how we came up with these magical rules. So let's get going. Process of differentiation turns a function into a gradient function. And so far, we've been using these basic rules to differentiate polynomial. Basic rules, you remember, the 2 comes out the front and times is by any number out the front. And then we take 1 off the power of 2 to get a power of 1, which 3x squared would differentiate to 6x. Remember, gradients we think as rise over run. What we're going to do in this video is show you how this all started again, how it basically started from scratch. If you haven't watched the videos on limits, which are differentiation videos 24a and 24b, then please go back and watch those before you get started, because otherwise this ain't going to make much sense. All right, a couple of things to be familiar with before we get going. If I write fx, which is a flash way of writing y, fx equals 3x squared, and I differentiate it, it becomes f dash of x. If I ask you to work out f of 4, what I want you to do is take the number 4 and substitute it. The number in the brackets is the value of the x. Substitute it in for x and to go 3 times 4 squared and work out the answer. If I ask you to work out f dash of 4, what I'm asking you to do is to take the number 4, which is the x value, and substitute it into the gradient rule, because f dash is a gradient rule. And go 6 times 4 is 24. So just be familiar with that notation so that you get your head around what's about to happen. All right, let's get started. Here's a function. Looks like a parabola, but doesn't matter what kind of function. It's a function. Right, I'm going to pick a point on the function, and I'm going to draw the tangent. We're going to work out the gradient at that point. Right, so let's call the x value x, and the y value, let's call it f of x. Right, I'm going to pick the coordinate of that point is x comma f of x. Well, I'm going to pick another point further up here. I'm going to call the second point x plus h on the x-axis, and the y point is f bracket of x plus h. And that's the coordinate of the second point. If I was to draw, I'm just going to label them A and B, actually, make things a little bit easier for ourselves. If I was to draw a line between A and B, we could work out the gradient between those 2 points. Gradient is rise over run. The rise would be how much we go up in the vertical, which is going to be f bracket x plus h minus f of x. The difference between the y points. And the run is how far we run along in the horizontal direction. And in this example, it's going to be the difference between x plus h and x, which is that distance of h. So over here, I'm going to write down the gradient between points A and B. The gradient is rise over run, which is going to be the rise. We've just worked that out as f bracket x plus h bracket minus f of x. And the run is how far horizontally, which is h. So that would be the gradient between points A and B. But I don't want the gradients between point A and B. I want to know what is the gradient at exactly point A. What is the gradient of the function at point A? So what I could do is I could grab point B and slowly move point B closer and closer and closer and closer to point A. That's what we want. We want to know what is the gradient at point A. The problem is I can't get to point A. If I bring point B on top of point A, then B and A are at the same point. We have no rise, no run, and we can't get it. So what we are going to introduce are these things called limits. Limits is the value that we approach as we get close to that value. So here is the formula we've just developed. This is the gradient formula, and it's called differentiation from first principles. And in the next video, we're going to show you how to use this formula. Great, thanks for watching.